right, so today we're going to be working on multiplying monomials times polynomials. And we're going to just figure out that we can use a lot of the exponent properties, like power to power and the product rule, to distribute the monomial through the polynomial. And then we always have to simplify combined like terms and write in standard form. So as we start today, let's warm up with a simplification from some of the stuff we learned about yesterday. Go ahead and hit pause, see if you can simplify this, write it in standard form, and come up with the degree of your answer. All right, let's see how you did. So the first thing I have to remember is there is a -1 here and I need to distribute. So let's go ahead and distribute that. So -5, a negative is a positive. And a -1 times 3 is a -3x. Remember, when I'm distributing a coefficient, it's just the coefficients that change, not the powers. I'm going to go ahead and write these guys vertically underneath like terms. So I don't see another x squared, so I'm going to write that over here. I know it's a positive. I have a positive 2x, and my -8 can go here. Okay, I'm going to add down. That's a -13. My positive 2x cubed is going to drop. -3 plus 2 is a -1, and I have a positive 3x squared. That's dropping. Okay, so the first thing I need to look for is to put this in standard form, so I remember that it's alphabetical by power. So the one that has the most x's is the 2x cubed. So that one's going to go first. So that one's done. Then it's going to be the 3x squared. And the negative x, remember, I don't have to write the 1, and the -13. So that is now in standard form. Now, if I take a look at degree, I see that there's only one variable here and it has a power of 3. This one has a power of 2. This one has a power of 1. And this, of course, has a power of 0. The largest number is 3. So my degree is a degree of 3. Okay. So I want you to think back to our last unit where we were multiplying monomials, and we had something like this problem. Remember that you had to multiply the big numbers, or the coefficients, so 5 times 1 is 5, and then I had to add my powers, so 7 plus 6 was 13. So when we are multiplying monomials times polynomials, this rule actually still holds, okay, because we're actually going to be multiplying multiple monomials. We're going to be doing this process multiple times. Let's take a look at a problem here. Okay, so this is really a distribution, okay? So I'm going to start by multiplying these two. So -2 times 3 is -6. And how many x's do I have if I have a 2 and a 2? That's a 4. So -6x4, x to the 4th power, is my first distribution. Okay, let's go again. -2 times -7. Well, that's a positive 14. Now there's 2 x's here and 1 x there. That would be an x3. And the last multiplication, -2 times 10, that's going to give me a -20. And my x squareds just hang on. They don't have anybody to combine with, so they're just going to be there. All right, go ahead and hit pause, see if you can do the bottom one. Okay, let's see how you did. 5 times -4, that's -20. A 2 and a 2, that's a 4. Next set, 5 times 2, that's 10. There's a 2 and a 1, that's an a3. And last but not least, the 5 times a -7, that's -35, and I have an a squared. So hopefully you came up with -20a to the 4th plus 10a cubed minus 35a squared. Okay, so now let's take a look at something where there's double distributions, and let's make sure we do not lose our negative signs. So 4 times 3 is 12, and notice I don't have any extra d's, so I'm just going to distribute the number through, plus 20d. That's my first part. And then I'm going to go to my second one. Remember, this is a -1 with a d to a power of 1. So that would be a -1d cubed, because 1 and 2 is 3. Let's go again. Negative 1 times negative 7, that's a positive 7, and 2 d's. And last but not least, the negative 12 and the d. Okay, we're not done. We need to put these in standard form and combine like terms. So who's going to be first? Well, I see that I have a d cubed, so obviously that is the largest. So I can go ahead and write that out with a 1d cubed. Remember, that can also just be d cubed. So either one of those will work. And if I look at next like terms and think powers, I have a 12d squared and a negative or a positive 7d squared. So 12 plus 7, that's going to give me 19d squared. And last but not least, I have a 20d and a negative 12d. If I add those, I come up with an 8. So either one of those answers would work. Notice how it is in standard form. The easiest way is to pull them together in standard form like that. Okay, go ahead and hit pause and see if you can do this one. All right, let's see what we get. 15x squared plus 6x minus 12. So that was this distribution. And then I have a negative 7x cubed, a negative 2x squared, and a positive 3x. Okay, so combining like terms and looking for who gets to go first, I see that the 7x cubed is going to get to go first because that's the largest. The next set of like terms in my standard form are going to be my x squareds. So I have a 15 and a negative 2. I see that that's going to be a 13. Then if I go to my x's, I see I have a 6x and a 3x. That's going to give me a 9x. And the only one I haven't dealt with is my negative 12. And there is my answer in standard form. All right, so now let's take a look at solving equations with variables on both sides. So as we know, solving equations has to happen, or we should come up with like y equals 5, x equals 2. Let's go ahead and work through this and see what happens. We need to make sure as we're doing this, though, that we simplify fully on the left and the right before we start moving things left and right, okay? So let's make sure we've combined all of our like terms as simplified as we can to standard form on the left and to standard form on the right. All right, so let's distribute. That's a y squared and a negative 12y. And then I have another y squared and a 2y. And then I have my 25. So on the other side, I have a 2y squared plus 10y minus 15. Okay, so we have always worked to where you can only have 2 terms on one side when you're solving equations. Well, now we can have 3 because standard form of a quadratic, which is what these are with powers of 2, is ax squared plus bx plus c, because there's a power of 2 and a regular and then no variable. So we can have 3, no more than 3 on each side. Okay, so let's put our terms together. That's going to be a 2y squared and a negative 10y and a positive 25. So I'm going to go ahead and drop down this. All right, so hopefully you've noticed at this point that we see that these are the same, okay, which is important. Those have to be the same. If they're not the same, then we can't solve it at this point. So if I move my 2y squared, this is going to cancel, and so is this. So they have to be the same at this point in solving our quadratics, okay? Eventually we'll discover they don't have to be both factor, but they have to be the same today. So those have to cancel. I'm left with a negative 10y plus 25 equals 10y minus 15. So I'm going to subtract my 10. That gives me a negative 20y plus 25 and my negative 15. And if I keep going, I'm going to subtract my 25. And negative 20y is equal to negative 40. And I see that y is going to be 2. Okay, y is going to be 2. Now, if I wanted to check myself to make sure I'm right, I would check myself like I normally do. I would substitute in, and I can substitute into either this step, or this step. So 1, 2, or 3. And I should come up with a true statement. Okay, so checking to see that your answer is correct is the same way as we check always. Okay, go ahead and hit pause and see if you can solve this one. All right, let's see how you did. 2x squared plus 8x plus 7. X plus 8, I'm going to go ahead and just drop the parentheses because there really is no reason to have the parentheses there. I mean, there is technically a 1 there, but multiplying by 1 doesn't change anything. I have a 2x squared plus 2x plus 12. So this side's fine. There's 1, 2, 3. That's in standard form. That is fine. So I'm going to go ahead and rewrite this side and start on this side. So I see I have a 2x squared, which is good because those have to match. And x and 2x is 3x, and an 8 and 12 is 20. Okay, so I see these are the same, so I'm just going to cross them out because they're gone. 8x plus 7, 3x plus 20. Again, move your 3x to the other side. By subtracting, that's going to give me a 5x. Move my 7 to the other side by subtracting. 5x is equal to 13. And x is going to equal 13 over 5. And remember, when we solve equations, to simplified fraction form. We don't solve them to decimal unless it is a word problem that requires money or it started with decimals. Okay, I want you to hit pause and solve these problems, and then I will catch up with you and we'll see how you did. All right, let's do this. Let's see how we did here. So the first problem I should come up with, if I multiply here, 15y squared and a negative 6y. And that's done because it's already in standard form. The y squared is bigger than the y to the first. It's done. I'm going to go down. That is an 8x to the 5 because 1 and 4 is 5. That's my first distribution. Second distribution, notice there's an a. Well, the a's got to stay there. So negative 6 a x squared. The third one, plus 12 x cubed. Now, is that in the right order? No, it's in the wrong order because this one is a cubed. This one's a power of 2. So 8x to the 5, x to the 5th, plus 12x cubed minus 6ax squared would be my answer. All right, let's look at one that has multiple variables. So negative 20, and there's an x to the 1, and at 2 x's, that would be x3y. Multiply again, negative 4 times negative 12 is a positive 48. How many x's do I have? 2. How many y's do I have? 2. And negative 28xy cubed. Okay, this one is done because we are putting them in alphabetical order according to powers. So we're looking at our powers of x's that are going to control our order. So you notice that we have a 3 for the x, a 2 for the x, and a 1 for the x. So that is the order that one would be in. Okay, if I solve this guy, negative 2w minus 2 plus w, 7 minus 4w. I have, if I simplify here, that's going to give me a negative w minus 2, 7 minus 4w. I'm going to move my negative 4 by adding. So 3w minus 2 is 7. Add my 2. 3w equals 9. W equals 3. And my last one, n squared minus 4n plus n squared plus 8n, n squared minus 13n plus n squared plus n plus 16. Okay, like terms, 2n squared plus 4n, 2n squared minus 12n plus 16. The n squareds are going to disappear, and I need to move my 12n to the other side. So 16n equals 16, n is equal to 1. All right, let's get started on some homework today. Reach out to us if you're struggling.